Hello, APBIO. In this video, I'm going to talk about the factors that affect the rate of diffusion. So you can see them here. One of the factors that affects the rate of diffusion is the average kinetic energy. We know that we measure that with temperature. You can imagine that if you have more, the diffusion we've talked about is passive transport, which means that there's no input of energy required from a cell or from an organism if we're thinking about cell transport. And so it relies on the energy that's already in the system. You can think of it like that. So for temperature, it's a higher average kinetic energy with a higher temperature. And using that logic, you can see why as the temperature increases, you get a higher rate of diffusion. The second thing that affects the rate of diffusion is the amount of surface area. The larger surface area compared to volume ratio will allow for a faster rate of diffusion. This is what controls the size of cells, and we'll do a bunch of calculations that show mathematically why cells don't get larger than we see them. The largest cells are things like the egg cell, but most cells are much smaller, and they have all kinds of adaptations to increase surface area and keep volume nice and low so that the materials can get where they need to be and be removed at the rate which is necessary to sustain life. Concentration gradients are a third factor that are going to impact the rate of diffusion. The steeper the concentration gradient, the faster the rate of diffusion. And it's not any more complicated than that. So if you have a lot of stuff on one side of a membrane and not very much on the other, you're going to get a really fast concentration gradient. That's really important for driving certain processes. For example, it's important for the signaling in your nervous system, and it's also important for the generation of ATP. And we're going to talk a lot about concentration gradients and how they're used. Cells set up concentration gradients using ATP and then use really steep concentration gradients to drive a lot of processes. The size of particles is going to impact the rate of diffusion. You'll see larger particles are going to have a harder time diffusing, so smaller are going to diffuse faster. Just like a bunch of elephants that are scattering on a soccer field compared to a bunch of mice. Mice are going to be able to more quickly reach the edges of the field, and the elephants are all going to bang into each other. And not that we'd have mice and elephants on a soccer field, but anyway. And then the diffusion medium, meaning the state of matter, that how quickly things will diffuse. And a solid is going to be the slowest, and a liquid is going to be medium, and the gas is going to be the fastest. You can see the rate of diffusion is really fast with things like if you put perfume on one side of the room, you're really quickly going to smell it on the other side of the room. Okay, that's it for rates of diffusion, and I hope this was helpful.